Hey everyone, hope everybody had a good vacation, or not a good vacation, sorry, good weekend. Not sure what I was thinking. We're going to start with, we're going to do a quick review on segment addition postulate from Friday, and then we are also going to move into the midpoint formula and the distance formula, which we're going to use to find midpoints and distances between points on coordinate grids, which is going to be something we're going to need to use when we get later on into some of the geometry stuff we're going to do. We're going to do a lot of like geometry measurements and stuff on the coordinate grid. So I want to make sure we're able to do midpoints and distances to figure out what we're looking at. So let's get going. What we're looking at today is the segment addition postulate review we talked about was given any 2 points on a line, so like line segment A and B, they form that line segment. A third point lies between the given points if and only if the points are what they call collinear. And then that AC, the segment AC plus segment BC equals the segment of AB, the distance for AB. So we have our example in our picture. We have line segment AC, it's 4 units. Line segment CB is 6 units. The whole line segment is 10 units, so that works because 4 plus 6 is 10. So we can definitely say that C is between those 2 points A and B on that line segment. So that's what we're going to be able to do now too, is we're going to be able to determine is the third point between. Here they've given us 3 line segment measurements, and we're trying to determine if point B lies between A and C. So they told us A and C is 26 units long, and then that AB is 11 and BC is 17. So if if B is between A and C, if I add AB and BC together, which is 11 plus 17, that comes out to 28, which doesn't equal the distance from A to C. So that tells me that B is not between A and C on that given line segment. It may be off the line segment. It may be slightly different positions and stuff, but it's just definitely not between A and C. Does that make sense to everyone? We're going to be able to kind of look at stuff and add things like that together. Okay, we're mostly going to use this stuff, this midpoint, the segment addition stuff, to find lengths of different line segments as we go through the course. We're going to be given triangles, so we're going to have to figure out lengths of sides of triangles or lengths of sides of rectangles, and we're going to be able to use the segment addition postulate to kind of piece together what sides of triangles might measure. So here's another example. They've told us that point T lies between, and remember, if they're telling you that they lie between, you have to take it as a given that it definitely is, so you can set up your equation. So they tell us point T lies between points U and S on line segment US. They're asking us to find the value of X plus the values or how long UT and TS are given the following information. As you can see that there, UT measures 5x minus 3. The whole line segment US is 45, and TS is 7x. Excuse me, from the picture. So I can piece together, because they've told me that it lies between, I can piece together my equation that UT plus TS equals US. I know that's going to work because they've told me that T is between 2 points. So we set up our equation. We plug in 5x minus 3 for UT, 7x for TS, and then it all equals 45. And now we're just solving for X. We're turning it into an algebra problem. So we go through our steps. We combine our like terms. We then move 3 to the other side. So we end up with 12x equals 48. We divide both sides by 12 to get x all by itself, and we find out x equals 4. So now I know that we wanted, as part of the question, find the value of x. We're 1/3 done. X was 4. The measurement of UT now, we're just going to plug 4 in for x. So we end up with 5 times 4 minus 30 is 17. So that's what UT measured. Same thing for TS. TS was 7x. We plug 4 in for x. We find out that that equaled 28. If you want to do one last quick check, 28 plus 17 is 45. So everything does work out, and we found all the right measurements. That makes sense to everyone. That's a review from what we did on Friday. Okay. Moving on to the midpoint of a segment. Take a quick minute and try to think of what the midpoint of a segment is and see if you can define it. Okay. A midpoint of a segment is the point halfway between the two endpoints on a line segment. it can be divided, and it can be anything can create it. It can be another line segment. It can just be a point. We just know that it's in the middle. So if M is the midpoint of AB, then AM is going to equal MB. It's going to create equal congruent line segments because it is the midpoint. Remember, we're talking the middle. So each side equals each other. So we can do this on a number line pretty easily. To locate the midpoint, we're going to use this formula. x1 plus x2 divided by 2. We're just basically taking the average of the 2 points to get the middle. Kind of think back to old math with mean, median, and mode. The mean is the average of all the numbers, kind of falls in the middle. So that's what we're doing. We're just taking the average of our two values, adding them together, dividing by 2, and off we go. So here's our example. We're trying to find the midpoint between -3 and 5. If you want to draw out a line, number line to kind of look at it, you can. I just didn't do that here. I'm using the formula, x1 plus x2 divided by 2. So my formula is -3 plus 5. That's going to be divided by 2. When I add -3 and 5 together, I get 2. So it's 2 divided by 2. So the midpoint between -3 and 5 is 1. And if you kind of think of it, it's 4 units. It's 4 spaces from 1 to 5. It's also 4 from 1 to -3 when you look at the number line. So that does make sense. Okay, next slide is 3 problems for you to work on. Again, we're using the midpoint formula. Take a few minutes, enter your answers in the Edpuzzle, and then come back and check your work and see if you got the right answers. Okay, so here's what you should have gotten. The first one, the midpoint should be 28. Second one, your midpoint was 32. It's a little tricky because it was a negative sign. And then the third one was a little trickier because it actually ended up being a fraction. It should be 1 1/2 or 1 1/2 or however you want to write it. 3 halves, whatever you did, you should have got the same thing. -7 plus 4 gives you, actually it should be -3. My bad, that should be -3, not +3. So the midpoint should be -1 1/2. I am sorry about the typo or the miswriting on my slide. Okay, next one is a word problem. We're trying to find where we want a picture to be hung. So I'll read it with you and then give you a few minutes to try to solve it. Jacinta's hanging a picture 15 inches from the left side of a wall. How far from the edge of the wall should she mark the location for the nail the picture will hang on if the right edge of the picture is going to be 37 inches from the wall? So we know how big the picture is. We got to figure out the point where the nail is going to be. So we're just going to use the midpoint formula. I know it's not really a number line, but you do have measurements that you're looking at. So take a few minutes, try to figure it out, and then come back and check your work. Okay, so here's what we would have used. We would have counted the left side of the wall where the wall was. That is our 0 point. So we're trying to find the distance between 15 and 37.5. So we add those together. We get 52.5. Divided by 2, we find out that the midpoint where we need to put the nail, so we're talking the midpoint between the edges of the picture is what we're looking at. So the nail is going to need to be 26.25 inches from the left side of the wall. Does that make sense? Does everybody see that? Okay. Moving on. That was doing midpoint formula on a number line, or just 2 numbers. What we're more concerned about is finding the midpoint between 2 points on a coordinate plane. It'll be easy and very easy to do if either the x values or the y values are the same for the 2 points. So if they fall at the same y coordinate, it's basically just a number line then. It's just the differences in the x values. Same thing if it's the x values are the same, then it just becomes a number line on a vertical scale, and it's just differences between the y values that we're trying to figure out. What we usually have, though, is a diagonal line formed on the coordinate grid, and we have to use this midpoint formula. It's the same midpoint formula we used for the number line, or 2 numbers, and we've just done it 2 because we have to figure out the midpoint for the x values, and we have to figure out the the midpoint for the y values, and that's going to be our co-ordered pair. Remember, x and y is ordered pairs. We need to have 2 values to find that midpoint. So when we look at our examples, we're always going to just be x1, y1, or x2, x1 plus x2 divided by 2, y1 plus y2 divided by 2. It doesn't matter which is x1 and y1. It doesn't matter in this at all. So when we look at our example, we have a graph. We have points A and B. The points are at 1, 1 and 7, 9, and we're trying to find the midpoint of that diagonal line. We could maybe kind of look at it and guess where it would be, but if we use the formula, we can definitely find out what it is. So my formula, I'm just going to plug in the x and y values. I have 7 plus 1 for the x values divided by 2, and then 9 plus 1 divided by 2 for the y values. So that works out to be 8 over 2 and 10 over 2, which when we divide, we get our midpoint becomes 4, 5. If you look, it looks reasonable that would be the point, that would be the midpoint. So I'm not too concerned about having crazy numbers, but there are instances where you're going to get some crazy numbers because it's going to fall in between two numbers. So more often than not, you could end up with some half of a number. All right, so here's an example for you to try. Again, take a few minutes, plug your answers in the Edpuzzle, and then come back and see if you got it right. Okay, so again, we should have added the x values are 3 and 5, so we end up with 8 over 2. So the x coordinate, the x part of the coordinate would be 4. Again, we have 1 plus 9 in the y values, so it becomes 10. So it's the actual same midpoint as our previous number, our previous graph. It's just ended up being the same coordinate, just the graphs are different. All right, one more try for you. Again, another try it out. I've thrown in a negative number in there to see how you handle that. Again, figure it out, enter your answers in the Edpuzzle, and then come back and check and see how you did. Okay, we end up with 2 plus 6 over 2 for our x values. So that works out to be 4 again. And then our y values are negative 2 plus 4. So negative 2 plus 4 becomes positive 2. And now we divide that by 2 and we get 1. So that is where you should be putting in the midpoint on that. Again, we can kind of look at it and see, yeah, 4, 1 looks about right where we would expect it to be. Is that making sense to everyone? Okay. Excuse me. So we've been able to do it looking at graphs where we've had the points given to us on the graph or we've had to figure out the points ourselves. We can still do this without having a graph given to us. We can do it through ordered pair. So here's an two-ordered pair. We're trying to find the midpoint between negative 4, 7 and 14, negative 23. Again, it's the midpoint, so we're going to use the midpoint formula. We're going to throw everything in the m equals x over x plus 1, x1 plus x2 over 2, and y2 plus y1 over 2. So we plug in our numbers here, and we end up with negative 4 plus 14 divided by 2, and then 7 minus 23. Because it would be plus negative 23, so I just did it 7 minus 23. So we end up with 10 over 2 and negative 16 over 2. So our point, when we simplify those down, is going to be 5, negative 8. So if you want to take a minute and kind of graph it out on a coordinate grid to see if it makes sense, you can do that, or we can just trust the numbers because math is usually good to be able to trust numbers like that. Does that make sense to everyone? Okay, so here we go again. Some problems for you to try. I want you to take time, go through the 3 of them, figure out where the midpoints are, and then come back and check and see how you did, and we will move on from there. Okay, so here's what you should have gotten. The first one, your point should be 2.5, 10. Like I said, we could end up having a half point because of the way the numbers work out, and 8 minus 3 is 5, so it becomes 8, or 5 divided by 2. Second one, you should have got 0, 0 the way that worked out. We had 4 plus negative 4 was 0, and 9 plus negative 9 was 0. So basically that's point on either side of the origin in quadrants 1 and quadrants 2. And then the last one, you should have got 4, negative 4. Does that make sense to everyone? Okay, I hope everybody kind of understands that. The wrinkle we can throw at you in this now is sometimes you're going to be given a midpoint and one of the endpoints, and they're going to ask you to find where the other endpoint of our line segment is. So in our example here, we're given a line segment that begins at the point 3,5, so that's one of the endpoints, and it tells us that the midpoint is at 8, 10. So we have to work from there. So what we're going to do is we're still going to use our same formula. We're just going to split the equations out into two separate equations. What we're going to do is we're going to find a midpoint of x, and then we have the midpoint of y. So what we're going to do is we're going to plug in the numbers we have. We have a beginning point and the midpoint, so I can set the equation up as the midpoint of x, 8, equals 3 plus the other value of x, I don't know what it is yet, divided by 2. Same thing on the y, it's 10 equals 5 plus some other number, I don't know what it is yet, divided by 2. Now we're just solving for x and y on each side to then eventually come back down and have our ordered pair at the end. So your first step is going to be to get rid of that fraction, so we're going to multiply everything by 2. When we multiply everything by 2, the 8 becomes a 16, and the right side just becomes whatever's on the top of the fraction because the 2's are going to cancel out. Does that make sense to everyone? So we end up with 16 equals 3 plus x, the second x, and 20 equals 5 plus y2. So now we're going to get the variables by itself. So we're going to subtract 3 from the x one, and we're going to subtract 5 from both sides on the y equation. So we end up with 13 for our x value and 15 for the y value. So that tells us that our endpoint is 13, 15. Does that make sense? If you want to think of it, we kind of look at the differences between the x and the y values of our coordinate points. They both go up by 5. If that's the midpoint, we're expecting them to go up by 10, so we're just going to add 10 to our x and y values. It does work out that way. It's a little bit longer way to do it if you can kind of see how it works. Sometimes it doesn't work that well, though. So we definitely want to make sure that we're doing it with the formulas to get the answers sorted out. Okay, so here's some examples for you to try. Again, take your time, plug the answers in the Edpuzzle, and then come back and check and see how you did. And we'll go through the answers when you get back. Okay. So this is what we should have gotten. The first one, your midpoint should have been 8, negative 2, plugging everything in. The second one, you should have gotten the endpoint. Sorry, the endpoint was 8, negative 2. And the endpoint of the second one should have been 9, 15. So if you have any questions, send me an email. Say, hey, Mr. Ford, I don't quite understand this. Can we go over it again on Tuesday or Wednesday, whenever it is, the next time I see you, so you can ask questions in person. I know it's hard doing it online sometimes. Okay, so when we talk about midpoints, we've worked with midpoints before as up to now. Now we need to talk about segment bisectors. And a segment bisector is a point, a segment, or a line, not often a plane, that intersects a line segment at the midpoint. What the segment bisector does is it creates two new congruent line segments. It's just like the midpoint. It's just crossing over your existing line segment at the midpoint. It is something that we will use quite a bit when we start working with triangles. As we move forward in geometry, we talk all about segment bisectors that help us get information from our triangles and help solve for different things. So our example here is we have the line segment JR, and we're trying to find with a segment bisector at point A, and they want to find how long the original line segment is if the equations are what the new line segments equal. So I know it's a midpoint, so I can set my equation, start my equation, always with the segment indicators. It helps me out with what I'm working on and trying to figure out what I need to do. So I can say JA equals AR because it's a segment bisector, it's a midpoint, the two sides equal. So then I just plug in my equations. 3x plus 9 equals 4x plus 7. We're going to get x by itself, so I end up subtracting 3x from both sides. I end up with 9 equals x plus 7. Subtract 7 from both sides, I find out that x equals 2. I'm halfway there. I know what x equals, but that's not the question. The question was, what is the length of JR? So now what I'm going to do is I'm just going to plug in. I know I can do JA plus AR equals JR. So I rewrite my equation, 3x plus 9 plus 4x plus 7 equals the length of JR. I'm going to plug 2 in for x into my equation. So I end up with what you see there, and then JR ends up equaling 30. So that's one way to do it. The other way to do it, I know that JA and AR are the same distance. So I could have just plugged x into one of those equations and then multiplied that one by 2 because I have two sides of my long line segment. Does that make sense? Okay, one for you to try now. Again, take your time. If you have to draw it out, that's perfectly fine. Start, go through, and come back and check your work when we are ready to move on. Okay, so here we go with what the answer should be. We should have gone through and found out that x equaled 6. We set the two equations equal to each other, solve for x. They wanted to know the full line segment length, so we plugged the 6 back into one of the other equations. We would have had 6 times 6 minus 4, works out to be 32. 32 times 2 is 64. You could have done it the long way, you got 64. But now I know that my line segment is 64 units long. Does that make sense to everyone? For midpoint formula and midpoints and segment bisectors and trying to find the middle of all of our line stuff. Because like I say, it is a very important part of geometry as we move forward through this. Okay, we're going to move on to the distance formula now. We're going to talk about it in two different realms. The first one is just the distance formula on a number line. The formula we're going to use for that is the absolute value of one value minus the other value. It doesn't matter the order. It's just going to be one of your values minus the other value. Take the absolute value of that because it's a distance. Distance doesn't have, it can't be negative, so we have to look at it as the absolute value of it because it is still a distance. So if we look at our example on the next page, use the number line to find QR. They're showing Q is at -6, R is at -3. We want to find the distance. We can count it. We can see that it's 3 by counting it, but we're going to use the formula. So QR is the absolute value of the x values minus one x value minus the other. So I did -6 minus -3, which becomes -6 plus 3, again, all in the absolute value symbols. So I end up with the absolute value of -3 for QR, which simplifies to 3. Remember, absolute value is just take whatever's on the inside, get rid of a negative sign if it's there. Okay, so here's one for you to try. Again, take your time, go through the equation, and enter your answer in the Edpuzzle to see how you did. Okay, so this is what you should have got. We should have had 14. You could have counted them up. 6 to 0 is -6 to 0 is 6 spots. 0 to 8 is 8 spots. 8 plus 6 is 14. It works that way as well. But the formula is the absolute value. So I did -6 minus 8. I got the absolute value of -14, which simplifies to 14. All right, one more for you to try. Again, take your time, enter the answer in the Edpuzzle, and come back and check how you did. All right, this one here, you should have got 8. We would have had 5 minus 3, or -5 minus 3 becomes -8. You might have done it the other way. 3 minus -5 becomes 3 plus 5, and then you see that it's 8 without really having to worry about the absolute value. That's a number line. That's easy, but we don't use number lines in geometry. What we use is the coordinate grid. And the coordinate grid for distance formula is a little bit crazier and a little more complicated, and the formula has everybody's favorite, a radical. But here it's the same thing. We're still taking the differences of our x values, which is our number line. Think of our number line as the x-axis. We're also taking the differences of our y values because we need to kind of look at over the course of the diagonal line, there's like we have to do the difference. We have to end up taking the square root of it. You'll see tomorrow when I kind of go over this again, we're going to do a little more distance formula tomorrow. I'm going to bring in an equation that I think people have heard of and kind of see how it all plays out and ties together. But this is the distance formula. x1 minus x2 squared, the difference of that, all squared, plus the difference of y minus y, again, all squared. Again, it doesn't matter which x is x1 or x2, but it does depend on if you, whatever you pick as your x1 value, the y that goes with that on the coordinate has to be the y1 value. We can't be flipping those around because it kind of messes up some numbers sometimes. So here's our example. We're trying to find the distance between points 4, 7, and 7, 15 on our coordinate grid. So I plugged them into the equation. I made the first values the x1, the y1, the second coordinate, the y2, the x2, and the y2. So 4 minus 7, again, all squared, plus 7 minus 15, all squared. When I do that, it's negative 3 squared. Keeping the negative 3 in the parentheses, so then we're squaring the negative 3. Same thing with the negative 8. We're squaring the negative 8. So we're going to end up with 9 and 64. We add those together. We get the square root of 73. We worked on simplifying radicals in the last unit. This is one of the things we're going to have to simplify radicals for as we're trying to find distances, because we need an exact distance. The problem here is 73 is a prime number, so we can't factor it out. So it just stays the square root of 73. All right, everybody, try the next one for yourselves. Again, enter the answers in the Edpuzzle when you figure it out, and then come back and check your work. Okay, so here we plug the numbers in. I did 12 minus 7 squared plus negative 15 minus negative 3 squared. That becomes 5 squared plus negative 12 squared. So it's 25 plus 144, which works out to be the square root of 169, which is a perfect square. It works out to be 3. Does everybody see that? Does that make sense to everybody? Like I said, we're covering the distance formula quickly here. We're going to do a lot more of it tomorrow. I just wanted to introduce it here today so you can see it and move on from there. All right, so there's homework out on Google Classroom. Double check that. What we're going to do tomorrow or Thursday, you should see your grades in for the test on Tuesday now. I should be able to get them in Tuesday. What I'm going to do Thursday when you guys come in is the first part of class is going to be our test correction portion of the class. So I'm going to go over the test. I'm going to go over every problem. If you have any points that you lost on any of the questions we go over it, I want you to be filling out your test corrections as we go over them, so that you can see what you're doing, and then you'll be able to pass those in and get back the points that you lost. All right, so everybody have a good night, and I will talk to you all tomorrow.